Okay, thanks everyone for joining today. My name is Asif Wakar. So I'm a Microsoft MVP and one of the organizers for Singapore Microsoft Azure community in Singapore. Nilesh was previously one of the organizers for this community for a very long time, and he did a lot of good sessions and organized a very good big events, Azure boot camps, and past couple of years. Yeah, fortunately, unfortunately, he's not here now. He's moved to Australia and he's connecting from there, from Melbourne. From past 1 year, he's in Australia. So yeah, if you don't know about this community was started in 2011 and it's been almost 10 to 15 years and more than 8,000 members we have. So this is a Facebook group we have, MS Technical Community. So if you have any doubts or clarification you need, there are a lot of experts there. You can reach out there. And this community is not only specific to Azure. We have Microsoft 365 Power Platform. Everything is in one place. So this is the link, meetup.com MSSEUG. I hope you have signed up from there. But if not, then you can see all the sessions are announced on this community, not specific to Azure, but all the other communities also you can find out from place. We also have one YouTube channel. So the session recordings will be available later on the YouTube channel. So currently we have Santhamil is also one of the organizer for this community. So if you have any clarification or if you want to present in the community or host any sessions, happy to reach out one of us. Or you can also ping to Nilesh. He's still active quite. Yeah. So we have done, you can see some of the sessions from Nilesh as well. We have done a lot of good sessions in the past. All are available on our YouTube channel. In today's session, Nilesh, it's a very interesting topic. You know that, right? Everywhere, the AI boom and the API management, how you can leverage the AI capability. Nilesh will be talking. So Nilesh is a Microsoft MVP and cloud solution architect, working in Eminet in Australia, Melbourne. And before that, he was working for DBS Bank as an enterprise architect a couple of years. And he have a really good experience in big data and other topics. So if you want to reach him out, I think, yeah, you can. There is a Twitter. He's quite active on Twitter and the LinkedIn. So we have also announced one new session that's going to be on 31st July, mastering MCP with multi-agent architecture, and it will be done by Buma. Buma is also MVP, Microsoft MVP. She is based in the US. So yeah, she will be. So if you are interested, you can register for the event. It's already announced on the meetup.com. And we also have 2 more sessions coming in August from David and Divya. So it's more on the multi-agent on Azure, more on the AI topics. So again, and in September, you'll meet again with Nilesh and one more person in the community. So yeah, I will announce the session soon. And we also have done some of the good chart buster sessions in previous. So if you are interested, you can take a look. And this is our community meetup group. If you haven't subscribe the channel, you can scan the QR code and do that. Last but not least, just a few reminders, housekeeping rules. Please keep yourself on mute. If you have any questions, you can use the raise hand feature. This session is being recorded, and if you like the session, please help to spread the word on social media. Yeah. So thanks. Now, stage is yours, Nilesh.
Thanks, Asif. Thanks for the wonderful introduction. Let me know once you're able to see my screen and you can hear me clearly.
Yeah, we can.
Okay, so I'll switch to the presentation first before getting into the demo mode. And okay.
Yep.
Can you see the title slide?
Yeah, we can see.
Okay. So today we'll be talking about API management in the AI era. And oops, come on, move here. Okay, let me position this here. So a bit about myself. Asif already gave a quick intro about me. So my name is quite unique, the combination, the first and the last name, and I never had problem getting social media profiles with that combination. So you will find me everywhere with that Nilesh Kule as the handle. I like the game of cricket. So if anybody is interested in talking about cricket, that's another area other than tech where I can be quite opinionated. I've been a Microsoft MVP since 2017 or 2018, and for last couple of years, I've also been a Docker captain for my contributions to the container-based technologies and public speaking around Docker. So today we'll be talking about how to use the Gen AI capabilities for API management. Nowadays, you hear everyone talking about generative AI, and people are trying to infuse AI into their applications. So this particular slide, it shows what are the different capabilities that API management has at a very high level, and then how this capability or feature related to AI gateway, which focuses more on the AI models and inferencing of those AI models. What are the different features which API management offers? Azure API management has been around for quite a long time, and it's an enterprise grade API management solution. It has a lot of features for managing REST APIs and SOAP APIs, the normal APIs. But when we are dealing with generative AI, we need some modifications to the traditional way we are managing the APIs. So recently at the Microsoft Build event, there were a lot of capabilities which were announced as part of this AI gateway. Some of them are in GA, some of them are in preview, and some of them have been already available for a bit of time. So I will share these slides. They are already there on speaker deck and the slide share, so you can refer to them later. We will look at some of these capabilities. Now, when we are dealing with Gen AI related APIs, there are some challenges that we need to be aware of. If you work with any of the generative AI related tools, ChatGPT or Cloud or GitHub Copilot, anything that uses the generative AI, you would have known that it uses the currency which is based on tokens. So we're dealing with number of tokens, and it's very important to understand the usage of these tokens. We want to make sure that whoever is using our application, how many tokens they are consuming or how many tokens they are using. This tracking is required when we have like a shared environment. Let's say we have an instance of Azure OpenAI, and there are multiple teams accessing this particular Azure OpenAI instance. Then we want to be able to track which team is using how many tokens. The next thing is to manage the tokens per minute quota. This is again handy when we are dealing with shared environment. If multiple teams are using the same instance of the Azure OpenAI or large language models, we don't want that one particular application sends a lot of requests and then it exhausts the tokens per minute quota for that particular instance. In such cases, the other applications which are accessing that particular instance, they will not be able to work as expected. Third thing is about the security. When we are dealing with these APIs, we don't want to share the keys which are used to access those APIs. So securing those API keys is another challenge. And the last one is about distributing the load across multiple endpoints. So this is a case where we have like a provision throughput, which is like a set number of capacity for tokens. And once that is finished for our primary source, when we want to have high availability and resiliency in our architecture, we want to fall back to a backup instance. So this is another scenario where we want to make sure that before we fall back to the backup instance, we maximize the usage of the primary. So these are some of the challenges we will come across when we are dealing with the Gen AI related APIs. And in this session, we will see how to address some of them. Now, I talked about the provision throughput or PTU. This is one mechanism by which we can get like throughput, which is not at the model level, but at the subscription level. Usually when we deploy a model, the limits or the quota are applicable to the type of model or that particular deployment. Like if I'm deploying GPT 3.5 turbo model, then there will be a set of like quota associated with that. Same thing goes for GPT-4 and GPT-4o. But then if I want to use these multiple models together and I want to combine the throughput of that, I can use this concept of provision throughput. So it's like allocating a large chunk and taking it at the subscription level instead of doing it at the particular instance level of that model or particular deployment level. And this allows us to have some cost savings. And I've put a link here which talks about how we can optimize the cost using this approach. So let's get into demo mode and see how to use these things. Now, before I go into the token matrix emitting, I want to show how the tokens work. So here I have LM Studio, which is a tool you can download locally on your machine, and you can run these large language models offline. So currently I have this Minstrel 7 billion instruct model, the V0.3. And let's say I want to ask a question here. Let's ask a very simple question saying, tell me something about Singapore weather in the month of July. And I'll just copy this for the next one as well. So when I ask this question, Mistral 7 billion instruct model, it tells me, okay, sure, in July, Singapore experiences its monsoon season with high temperatures, heavy rainfall, and it gives the temperature range and other things related to the weather in Singapore. Now, here we can also see how many tokens are being used. So we can see that for this particular response to my question, it's using 141 tokens. Now, if I switch over to a different model, so let's say I want a DeepSeek model, which is a reasoning model. Now I've loaded this DeepSeek R1 Distill Llama 8 billion parameter model, and I will go and ask the same question. Tell me something about Singapore weather in the month of July. So we can see here that it's thinking, it's reasoning, and then once it gives the response, the number of tokens that it uses would be different compared to the Mistral model that we used earlier. So in this case, it's using almost 1,000 tokens. So we can see that based on the type of model and the number of parameters and the different settings that we use, we could end up with completely different set of tokens that are used. And this is applicable for the hosted models as well, where we might be using GPT-4o, Minstrel, or other models. Depending on how many parameters and what configuration we use, the number of tokens utilized would be different. And we could be paying quite a different amount of charges based on the model that we are using. So the first demo I want to show here is how we can use this feature in the Azure API management, which is called as the token matrix emitting. So the scenario we are trying to see here is when we send a request to the API management, which is going to do the inferencing for OpenAI model, GPT-4o model, it's going to emit the metrics. And then we can visualize those metrics using the Azure Monitor and Application Insights and see how those different tokens are getting utilized for different requests. So I'll switch over to the portal and show you what are the setup we are having for this demo. So here I have a OpenAI instance, Azure OpenAI. This is in the Australia East region, and I have a API management as well. Let's first go and look at some of the things related to this OpenAI instance. So this is using a standard pricing model or SKU. And the easiest way is to go to the AI Foundry portal to find more details about this. So if you have not used AI Foundry or heard about AI Foundry, it's the new portal for the AI services. This is like, it consists of the model catalogs. It consists of all these playgrounds related to the chat, assistant, video, audio, image, completions, everything, and the tooling as well. So we can do all things around monitoring. We can do deployments of the new models. All that can be managed via this Azure AI Foundry. And here we can see that this particular deployment is using the GPT-4o mini model, and the version is 2024 July 18th. We can also look at various other things like deployment. I can go into the details and we can see the deployment type is global standard here. Capacity is in terms of the rate limit, the tokens per minute, we are setting this to 20,000. And same way, we can go and look at the other models as well. In case we want to deploy any other Azure OpenAI model, there are 40 models available. We can pick anyone from this. It could be GPT Mini Audio Preview, for example. And these 40 are related to the Azure OpenAI. There are also models which are outside of the Azure OpenAI, like the open source model, like the DeepSeek model here. And if we go to the full model catalog, we will see here that there are more than 11,000 models available. So we can deploy any of these available models onto our instance of the Azure AI Foundry, or we can manage those models using the Azure AI Foundry. Now, that model is available for us to work with from the API management. So in API management, if I go into the properties of this, I'm exposing the OpenAI API endpoints. So these are the endpoints related to the chat completion. So we can see there are different post methods here. One which creates a chat completion endpoint. There is one which creates the batch images. And these are 5 or 6 different operations which are exposed as OpenAI API endpoints. Now, the interesting point here is in terms of the policies. Let me just reduce this, and hopefully you can see the policy definition here. We are defining a policy which is doing the authentication part in the first place. So this is where we don't have to exchange the API keys between the services. We can do the authentication using managed identity, and this improves the security posture of the interaction between the API management and the model, which is hosted on the Azure AI Foundry. From this managed identity, we are getting the bearer token, or using the managed identity, we get the bearer token for the authorization. And then we are setting the backend as that OpenAI backend. And in terms of the emitting of the tokens, we are saying that we want these particular properties or these different dimensions to be emitted. And it will go, and every time a request is made, it will write these properties into the log. So we have the subscription ID, the client IP, API ID, and the user ID coming from the context. And based on this, then we can build visualizations to see who is using how much of the tokens. So in order to do that, let me switch over to Visual Studio Code and generate some workload here. So I have a small Python script here, and I've gone and executed some parts of this. So this is what I've done, and this is what I showed you earlier, that we are creating this OpenAI model, GPT-4o global standard with this particular model version. Then we go and use Terraform to deploy all these resources. Now, we have created 3 subscription keys here. And when we send the request, we will be requesting using the combination of these keys. So if I go back to the portal again, and we look at the subscriptions, we will see that there is subscription 1, subscription 2, and subscription 3. So these 3 keys is what we will use interchangeably to send the request. So let's send this test, or let's test that API using this call. So let me just clear this output. And we are trying to send 10 requests here, and it will use those. Currently, it's using just one key, subscription key. So we are sending this message, or we are sending this prompt. So in terms of the messages, we are creating 2 roles here. One is the system role, which gives a bit of context to the LLM, where we say you are a funny, helpful assistant who answers in a true Singaporean way. And the question or the prompt that we are sending here as a user is, why should I attend Azure Singapore meetup session by Nilesh? So let's see what does it come back with. And I'm expecting 10 different responses here. So let's see in the output why the GPT-4o says we should attend, or you should attend my session. So in the answer, it says, if you don't attend the Azure Singapore meetup session by Nilesh Gule, you may regret it. Here are a few reasons. It says local expert, networking, real world insights, Q&A opportunity, free food. So I don't know if Asif is sponsoring food today, but okay, it is coming up with these reasons. That's one response. And similarly, we would get 10 different responses. So you can see that it's using this, ayo, why not, like Singaporean slangs here to come up with 10 different, if not unique, but 10 different responses. And with that, the first request is sent using just one subscription key. Here, it's using the same subscription key 1 all the time. Now let's go and run this with the other subscription keys as well. So we are sending now another 10 requests here, but we'll be using a combination of subscription key 2 and 3. So let's run this. And while this is running, I will go and create a visualization in the portal. So we can go back to our resource group. We have the application insights here. Under the matrix, we can find the matrix related to OpenAI as part of the custom matrix. And it has these completion tokens, prompt token, and total tokens. So completion token is consisting of the response which comes back as the output of the prompt that is sent to the model. And prompt tokens is whatever prompt we are sending, that also requires some amount of tokens. So we will use total tokens here, and let's do a sum. We'll also apply splitting, and let's split it based on the subscription ID here. And instead of line chart, maybe we can do area chart. Let's say last 30 minutes. So here we can see in the last 30 minutes. So this is that first call, which came with just subscription ID 1. And then we use those all three IDs. So we can see using each subscription key, how many tokens are being used. Now, again, if I go back into Visual Studio Code here, we will see that the number of tokens which are used would be different for each response, because I'm not getting the same response. The content that is returned is different every time. So because of that, we will see that the number of tokens are different between different subscriptions. So this is one way we can identify based on the subscription key and using that emit token policy, which user or which application is consuming how many tokens. Once we have identified this, the next thing might be we want to limit the number of tokens. So that's the second scenario where we want to do the rate limiting. So usually in traditional API management, we would do rate limiting based on the number of requests within a particular span of time. But with tokens, it is, or with GenAI, tokens being the currency here, we can use that token usage as the approach to limit the number of requests which are sent. So here, what we are trying to do is enforce the limit on the number of tokens that a particular consumer is using when they are requesting the LLM to perform some operation. So for this, let me again switch back to the portal, and I will use another resource group. So here again, I have Azure OpenAI instance running in Australia East, and the API management service. It again has that same OpenAI APIs exposed. And if we look at the subscriptions here, we have just one subscription. Now, the policy that we are going to apply here is not the rate limiting, not the emitting of the tokens, but the rate limiting one. So if we look at this definition of the policy, the first part remains the same, where we are authenticating using the managed identity and getting the bearer token. We also have the backend service as the OpenAI. But the policy that we use here is open token limit or OpenAI token limit. And we are going to do this based on the subscription ID. And we are saying the tokens per minute that a subscription ID can use is, let's increase this to, let's say 2000 instead of 500 tokens. So in a span of 1 minute, the maximum number of tokens that can be used is 2000. So let's go and trigger some workload for that. So we will do the similar thing here, and I will remove my name. And as Asif said, there are a lot of interesting things being done as part of Azure Singapore meetup. So we'll ask the question like in a generic way, why should I attend Azure Singapore meetup here? And we'll send 10 requests. So we get the response again saying it's again networking, learning opportunities, hands-on experience. 2 requests have gone through. Third one. So we have completed 5. Seventh one is taking a bit of time. Okay. Usually it fails around 8th or 9th request, but let's see what happens here. Okay, so it looks like it went through with all the 10 requests. Let's trigger it one more time. So, okay, let's send 20 requests this time. And here we can see that for the 5th request onwards, we are getting this 429 status code, which means that the token limit has exceeded. And it says that, okay, try again in 2 seconds, because we gave that limit as 1 minute, 2000 tokens within a minute. So it knows that there is still 1 second remaining for that time frame. And after that 1 second, again, it starts giving as the 200 response here. So this way, we can limit the number of tokens that are used by a particular subscription. Now, 1 minute is too short a time frame, but you can set this time accordingly, like maybe per day or per week, and the number of tokens that can be consumed by a particular consumer using a subscription key to limit how much usage can be used for the tokens by that consumer. Now, the third scenario I want to demonstrate here is regarding load balancing and circuit breaker. In this case, we want to use the provision throughput to have a primary endpoint for our model. And then we also want to use a backup. Like if the primary endpoint is exhausted with its token limits and the quota, then we don't want the application or the consumers to stop working. We want to fall back and use a secondary instance, and we can also use either round robin, weighted, or priority based load distribution strategy for this. So once again, let me switch back to the portal and go into the resource group where we have this load balancing related resources. So in this case, what I have done is I have created 3 instances of the OpenAI model. The first one is in Australia East region with priority 1. And then for priority 2, which are my backup regions, I have East US and South India. And they're all using GPT-4o model with the same API version. So these are the 3. We can see here that one is in Australia East, the second one is in East US, and third one is in South India. In terms of the configuration, when it comes to the API backends, here we are configuring all 3 as the backend for the API. So the runtime URLs of all those 3 OpenAI instances are configured as the backend for our API. And then when we go into the policy for this, there is a configuration related to the backend here for the load balancer. So in the backends, we can here configure again which backends we want. So all three are configured right now as the backends. And then when it comes to the backend weightage and the priority, we can use even distribution like round robin, or we can customize based on the weightage and priority. So in my case, I've given that priority 1 is 100% weightage for the first instance of OpenAI. And then the rest two, they have got priority 2, and the split is 50-50, like equal splitting between these two. So we can change these priority numbers and the weightage as per our needs. So the scenario that I'm trying to replicate here is whatever is the throughput or whatever is the quota for the first instance, once it gets exhausted, I want to fall back to the other two. So in this case, that is again managed via the policies. So if I go back into our API and look at the policy for this, we will have that policy definition, which says that in case of status code as 429 or 503, and it is related to the backend pool where it does not contain this reason as temporarily unavailable, based on this condition, you fall back and then use the retry mechanism. So that is the way after 2 retries, it will go and use the fallback mechanism. So let's go and again generate some workload on this particular instance now. So we are going to send 30 requests here. Let me clear the output. The question is same. Why should I attend the Azure Singapore meetup? And it gives us the output with the token number of tokens, like 222 for 7th request. It's being served from the Australia East region, which is my primary region here, or the primary instance. So all the first 6 requests, they all have been served from Australia East region. And here we see that the request number 21 has been served from East US, which is one of the backup region or the secondary instance. Then the number 22 request has been served from South India region, and then it falls back again to East US and then goes back again to South India. So this, we can plot a graph of this execution. And we can see that the majority of the requests, they were served from my primary Australia East, but then there were 4 requests which were served from East US and 3 requests which were served from the South India region. So this is again very handy when we want to load balance things across different instances of the backend service. There is another use case which I haven't set up a demo, but I can still explain it how we can use this. There is this concept of semantic caching, and this is again related to reducing the cost of the tokens. Now, let's say we have a query which is semantically same. I asked that question, like, tell me something about Singapore weather in July. If someone else asks a question which is having a similar meaning, it could be like, how does the weather look like in Singapore in the month of July? Now, the LLM is going to probably give almost same answers to both these questions. So for such kind of things, we don't want to exhaust, or we don't want to use the tokens from the large language model. We could cache the response and store the semantic meaning of the question. And if it is semantically same within the thresholds of some bounds, then we can serve the same request from our cache, which can help us to reduce the cost of the hosted models and the usage of those tokens to a great extent. So with that, I have come to the end of this session. In summary, what we looked at is when there are multiple applications using same instance of your LLM, we could track that using the emit token metrics policy and the subscription key. We can also ensure that a single app doesn't consume the whole tokens per minute quota by using the token rate limiting policy. And then we can secure the API keys across multiple applications by using that the managed identity. And to the next level, we can still use the Azure API management provided subscription keys for the consumers. So this is same as like normal subscription keys that we use for the REST APIs. And finally, we looked at distributing the load across multiple endpoints for high availability and resiliency kind of scenario using this backend pool and the circuit breaker technique. Here are some of the resources I found useful when I was looking at these different options. So there are things around the gateway topologies, the OpenAI token limit policy, the emit token policy, and the matrix policy that we looked. I showed the Azure OpenAI related ones, but if you're using an open source model, then similar to the OpenAI token limit policy, there is a LLM token policy, and there is an equivalent of the LLM emit token metric policy as well. So if the model that you're using is different from the Azure OpenAI, you could still use these other policies to implement similar features. If you like YouTube videos, then Hussein Dalai, who was a Microsoft MVP before, and he's part of the Microsoft team now, he has a series of videos about using these the API management and the GenAI gateway related features. And what I showed here in terms of the demos, they are coming from the GenAI labs. There are more than 20 to 25 different demos related to the GenAI capabilities. So you can try them out yourself. Thanks for attending the session. I really enjoyed sharing this with you guys. Hopefully you found it useful. And in case you would like to have a look at the source code, it's available on GitHub. I created minor modification to the actual GenAI labs to do it as part of the Australia region and the South India, but the original labs, they are using different regions. You could look at both of them. And this particular slide, as well as some of the other slides of my public talks, they are available both on SlideShare and Speaker Deck. Thanks once again. If anyone has any questions, I'm happy to take them.
Thanks, Nilesh, for the wonderful session. I think there is one question. When deploying OpenAI models in multiple regions, and in case of failover and routing changes, how to maintain chat thread sessions? This is Brijesh asked this question. So maybe Brijesh,
you would have to externalize your chat thread to like something like Cosmos DB or a data store, which is outside of those models and the region. So
okay,
your models would be deployed in different regions, but your chat thread can be maintained in maybe Cosmos DB or even for that matter, I think Postgres, for example.
Okay. Okay. Got it. Thanks. And there is one more question is there, just now you say, right? So whenever, we are asking the same question, for example, again and again, right? So you said like we can get from the cache, but for example, weather is change every hour, right? So suppose if I ask some question like, okay, how's the weather now in Singapore, and whatever answer we got it, we keep it in Redis cache, for example, Redis cache, right? Then
Yeah.
after maybe half an hour or 1 hour, again, if somebody asks question, then they will get from the cache, right? Maybe then cannot be
You can
accurate.
define the duration of the cache. That's a
Oh,
very
okay.
good question. Like
Okay.
you can define how long that cache entry is valid. So
Okay.
if it is within that 1 hour time frame, then you can return the same answer. Otherwise, it will go and regenerate the answer.
Exactly. Exactly. Yeah.
Yeah. Yeah.
Okay. Understood. Understood. Thanks. Yeah.
Yeah. Thank you.
Anyone,
Thanks for that question.
anyone have any other question? Okay, I have two questions. Maybe Nilesh, you mentioned earlier, right? You showed the models, the list of the models which we can choose and train. But
Yeah.
how to choose those models? I mean, like which model is fit for our use case? And yeah, so as a beginner, I think how we need to uh, select those.
Microsoft is making it easier for you. There is a feature called Model Router. So if you go into, let's say here, OpenAI, go to the Foundry portal, model catalog, you have this model router feature. So this can help you to save cost by choosing the right model based on the type of operation that you're trying to do. Otherwise, you can also use these things like you have these filters, like what is the kind of scenario or use case that you want to use the model with. You have the audio generation, you have speech recognition, chat completion, the completions, embedding responses, speech to text model. So you can use these filters to identify which model is suited for your use case.
Okay, thanks. And one more, I think it's relevant to the same topic. Let's say if we are working in medical or any insurance industry, right?
Yeah.
So, and we have a very specific use case for the topic like reinsurer, insurer to check the medical history or claims. So, can we have our own like the trained models, which is LLMs are available, so host on Azure Foundry, or these are the only predefined models are available to run on this?
No, you can train your own model. So if you look at these here, there was an option I saw earlier where you can train it. So let's go to one of the model. So let's say this one. And if you go into fine tuning, you can fine tune that model as per your needs.
Okay.
I also saw somewhere within this, you can add your own data files. You can create a custom model based on either this model, or you can build your own model. So that's possible. In this playground somewhere, there is that option where you can add those your own data, and you can customize the model.
Okay, thanks. Anyone else have any questions?
And Nilesh, one question I have actually for my use case. Actually, my use case is in my organization, right? We have some old technology project is there, for example, Camel and all, right? And the requirement is we need to convert that Camel project to the latest model like Spring Boot and all, right? So how we can use this OpenAI to convert that particular project into the Spring Boot application?
You could use like the Copilot and a model which is trained on the coding use cases, like what they call the codex-based model,
Okay.
not a general purpose model like GPT. So
Hmm.
you would need a model which is trained specifically with all your programming languages, and it can understand the structure of the projects and things like that. And nowadays, with the agent mode in Copilot or with the agent mode, you can do things like give it one project and say, okay, I want to convert it into another one, like Spring Boot, for example, and it will go and do all the heavy lifting for you. That's possible to do using the agent mode.
Okay, yeah, thank you.
Thanks. I think there's one more question in the chat. In load balancing, we saw 7 or 8 response came from the East US and 4 from the US and 3 from India. Is there we set which region is priority or a model to choose by itself?
Yes. So in our priority, when I set the backend, if you look at the, you're able to see my screen, right?
Yeah,
Still?
I can see.
Yeah. Okay. So in the backend configuration, you would see that the priority is second priority is for OpenAI 2, which is the East US model, and OpenAI 3 is South India model. So both of them have got the same priority, and the weightage is also same, 50-50. So that is why it is sending those requests to these two models on round robin basis. Does that answer your question? So it's based on the weight and the priority. So it's using these two properties here, or these two settings.
Yep, I think no more questions. Thanks, Nilesh. Thanks a lot. And thanks everyone for attending the session. And we have the next session on 31st July. So, yep, if you haven't signed up, please do. And thanks again for joining. Thanks a lot, Nilesh.
Thanks, Asif. Thanks, Nilesh.
My
Yeah,
pleasure.
Thank you. Bye.
Thanks.
so much.